Welcome. I'm so excited to be here moderating today's panel. Demand for electricity is only going up. Everything from air conditioners to data centers is adding load to the grid, and we need to meet that demand and also rapidly decarbonize our energy system to reduce greenhouse gas emissions and address climate change. Geothermal energy could be a major tool to help, and new methods of making this renewable energy source could be a major boon for our grid. Today, we're going to talk about that with some really wonderful experts. First up, we have Carlos Araque, CEO of Quaise Energy, a company working to use new drilling technology to unlock super hot, super deep geothermal. And also joining us today is Dr. Lev Ring, president and co founder of Sage Geosystems, a company working to build what it calls pressure geothermal. Thank you both so much for being here. So, I would love to have both of you kind of start us off by introducing your work in a bit more detail. You're kind of approaching this in slightly different ways. So, tell us a little bit about, the problem you're trying to solve, why geothermal is important, and your technology in a minute or so. Carlos, do you want to start us off?
I'll start. So we look at geothermal at Quaise as the most abundant resource of energy on Earth, period. To me, it's more profitable, more geographically agnostic, more scalable than oil and gas itself. So we're after unlocking that resource at the true scale of its potential. Quaise is born out of this desire to go after that resource in hotter rock to unlock better economics and deeper to unlock geography. Don't get me wrong, I think geothermal is already possible to do in the $50 to $100 per megawatt hour for all kinds, everywhere on the map for all kinds, and quite fast to meet the demand needs of today's energy transition and energy abundance. It's just the different flavors will do it at different speeds and different attributes. So happy to talk about that with you all throughout today's session.
Great. Thank you. Lev, tell us about Sage.
Yes, so we started Sage 5 years ago to develop what is called hot dry rock geothermal systems to harvest heat from rock where there are no natural aquifers. And so we pursue what is known as enhanced geothermal system concept. Pretty much you drill wells, you create fractures. We develop a specific variance of this approach where we don't connect wells downhole. We create fracture system attached to each well, and then we balloon this fracture system, and when ballooned, water becomes hot, we bring it back, and then we put it through what is known as organic ranking cycle and convert it back to electricity. And by doing this, we also discover that if we do it at a shallow depth, we can develop long duration energy storage.
Yeah, super interesting. Thank you. I want to dig in on that a little bit, Lev, and we'll come back. Carlos, I have a lot of questions about your tech too. Um, Tell me a little bit more about kind of connecting geothermal as kind of an energy producer, like something to generate electricity and also something that can store energy. I think that kind of combination is really interesting. Can you talk more about
Right.
that?
Right. So initially, when we started company, we were looking only to develop geothermal system. Storage was not part of our plan. But then, of course, we're a startup. We had limited amount of capital, and when you drill, the shallow you need to go, the less money it will cost you. And so for our tests, initial tests, we were going very shallow, and the objective was to see how this fractures ballooning and then producing is going to work reliably. And we did succeed in managing fracture system to operate in what is it, oil and gas uh, called half and puff, inject and produce. But because we were at a mild temperatures, we realized that we actually have a storage. We store energy by pumping water down the fracture system, and then earth stresses want to close fracture, and it causes water to flow back at high pressure. We put it through Pelton turbine, and we generate electricity pretty much exactly as pump hydro is doing, but upside down.
Great. Thanks. Carlos, tell me a little bit more about about the tech behind Quaise. So the idea is, somewhat similar. You want to get to hotter temperatures to make more economical geothermal, but part of that might involve drilling really, really deep. So tell me about the drilling tech that you guys are working with and how that's, important for the ultimate realization of this goal.
Yeah, so everybody in geothermal will tell you that if they could go deeper and hotter, they would, but they don't because they can't. That's the problem we're trying to solve. We're trying to access the hotter rock in more places. And that does two things. It improves the economics of geothermal. It actually brings geothermal to cost parity with oil and gas and even beyond. We're talking about $50 per megawatt hour at scale. And it also does another thing, which is geographical ubiquity. The drilling technology we've developed and is now field qualified and commercially relevant. It's no longer a lab technology is not meant to replace drill bits. It's meant to extend the capabilities of today's oil and gas drilling operations, where conventional drilling stops being economically viable, and that happens somewhere in the 3 to 5 kilometer depth range and somewhere in the 200 to 300 degrees Celsius range. Just at the beginning of the true resource potential, that's when we take over. That's when we go and push to hotter rock, deeper rock. The drilling tech is insensitive to the things that stop a conventional drill from going deeper. It's namely addressing three issues: is wear and tear of the drill bit. We don't have a drill bit, so there's no wear and tear. It addresses the ability to put power down the hole into the rock to destroy it. We do that by transferring microwaves instead of torque. And it solves for cutting removals. To make a hole, you need to remove cuttings from the hole. And because our cuttings are tiny, they're ash-like, it's easy to remove them with fluids. So that's really what we're trying to do here, is just really open the door for the resource to be tapped at the scale that's possible, and a scale that actually moves the needle on energy transition, energy abundance, and energy independence for everybody in the world, actually.
I got to see some of your drilling tech work. I got to visit earlier this year in Houston. It's pretty wild to watch that work. It's really interesting. I want to have both of you kind of talk a little bit about, this road. Often I think about, building a company as a road from, usually you start at some lab or some sort of innovation, take that and build a business with it. That's, like you say, commercially relevant, economically viable. So can you kind of sketch out for people, where are you on that road right now in terms of, what you have built, what you are working towards? Um, Carlos, why don't you, we'll
Yeah.
stick with you for a sec.
Yeah, I think the biggest frames the ambition of Quaise. So Quaise, even though we have very unique drilling technology that opens up the resource for everybody, our true ambition is to participate as energy developers. I always say we're not a drilling company, we're an energy company. And to answer the question of where we're in that journey, is we are building the first commercial power plant in the Western United States. So we're no longer talking about the drill as the main activity of the company. You've seen it, others have seen it. We welcome people to come and see it in person. It is quite remarkable. It's the first time in human history that we can actually drill hundreds to thousands of meters to the hardest rock without touching the rock. It sounds like science fiction, but it is very real. So to us, really the journey forward is let's bring electrons and let's bring heat online at industrial scales. We're building the first one. If you go and visit our Western project, the project in the Western United States, you'll see shovels in the ground, roads, pads, a drilling rig mobilizing. We're going to start drilling the appraisal well in November, and we'll do a flow test by the end of next year. We'll build a power plant producing electricity in 2028 to 30 timeframe. And we have a commercial offtake agreement for that. We're actually selling this electricity at very, very healthy profit margins while keeping costs of production very, very low. So the company is truly now a developer of geothermal assets of a very, very unique kind.
Interesting. Lev, what about Sage? Where are you on your journey?
Yes. So first, I want to agree with Carlos that today geothermal, almost all geothermal, with very few exceptions, are targeting this 200C or below 200C geothermal. And yes, we all can generate electricity at these temperatures, but levelized cost of electricity or cost of electricity simply happens to be relatively high. We still can make it profitable, but it is high. It may be in a space of 7 to 9 cents per kilowatt hour, depending on your scale. Well, if we go to 300 degrees C and above, as Carlos mentioned, then your power generation per well actually increases 10 times. Okay. And there are different technical challenges, but if we overcome these technical challenges, then we can estimate cost, and cost grows only 3 times. So as a result, the cost of electricity suddenly for geothermal becomes less than 4 cents per kilowatt hour, which is absolutely amazing because we can beat any other technologies, and it's pretty much unlimited. So how we can get there? That is kind of Shell sage final vision and goal, but it's the same as for SpaceX to go to Mars. It's very difficult to tell our investors we want to fly to Mars tomorrow. So our vision from the beginning, our strategy and technology staircase was okay. Let's get first to the low Earth orbit, which our storage. Then let's get to the 200 degrees C, and then let's get our frag down technology implemented and get to this very high temperature, 300 C degrees, without need to drill that deep, but only to frag that deep. And so, as far as where we are, we built our first storage power plant south of San Antonio, and UKC is very welcome to come and visit it. We signed a commercial agreement with Ormat, which is the largest geothermal company this year, and we got power purchase agreement from Meta. And so comes January 1st, we're going to start implementing first phase, this 200 degrees C geothermal at one of the Ormat facilities in the United States. And then from there, we're going to be at 300 C before the end of this decade. We are absolutely whatever Carlos is doing, and Carlos and I, we know each other, we talk all the time. Carlos' technology is going to be super helpful because for this superheat, we need to be between 8 and 10 kilometers deep, and there are tremendous challenges to get to this depth and this temperature with the current drilling and well completion technologies. But we're not waiting. We're using our drill shallow frag deep technology, but when Carlos comes, it's really going to help.
I just want to point out, I think that both of you said this and pointed out the importance of kind of finding ways to build and make an impact and, show investors and everybody else that, you're making progress in the road to that kind of ultimate goal of, these super deep or really ambitious projects. So I think that's just really interesting. Lev, I did want to ask you about the partnership with Ormat. How did you think about, working with an existing, really important
Yeah.
establishment there in geothermal?
So, what is one of the biggest commercial challenges for a company like Sage? Okay, it is how do we get from equity financing to project financing. Okay, we can raise a lot of capital, we can prove technology, but at some point to go to scale, you need to be able your projects and your company needs to be bankable. Okay, and there are a lot of technology risks, and bankers don't like technology risks. How do you get there? Well, that is the core of our partnership with Ormat, because they're largest geothermal company. They have multiple multi-billion dollars projects, and collaborating and getting access to project financing that they have helps to scale up our technology much faster than if we would be doing it on our own.
Great, thank you. Carlos, I think there's also, I know you have some collaborations as well, including with neighbors down there in Houston. Can you speak to that as well if you agree on the role of partners and specifically the role of the oil and gas industry being there in Houston and working with an established player there?
Yeah, so like Lev, I worked in the oil and gas industry for the better part of my career. We understand that industry quite well. The only way geothermal scales in a consequential way is for the oil and gas industry to engage. I mean, it's that industry can put terawatts of capacity on an annual basis if they mobilize towards geothermal. But they're very used to very high profit margins. The oil and gas industry is very, very rich, very wealthy in many ways. So to me, the best way to bring them to the table is not to ask for favors, not to ask for compromises and say, hey, guys, you should do this with us because it's cool and because it's green. I think the best way to do that is to say, hey, these projects are really, really profitable. You need to take a look at this stuff because what you're used to in oil and gas, those same capital structures and profit margins, we have them for you right here, right now. So please come in and do this thing. That's exactly what we're doing with this first project. If you look at this first project we're doing in Oregon, and it's a 1 gigawatt scale project, just to give you a sense for that, it involves a little army of partners. Neighbors is one of them, of course, and it's the one I will publicly share because they are an investor for a while now. But there's many, many others.
Mm.
You know, the Schlumberger's, Weatherford, Baker Hughes of the world, Halliburton of the world, they come in and do their job, and they get paid just the same. And the capital providers come in and fill in that equity stack, and the debt providers fill in the debt stack just the same because the risk reward is there. So that's how we bring these projects online, not only at that one side, but worldwide. To us, there's no other way. You know, one company, Quaise, going at it in a vertically integrated fashion and building a project at a time, that's going to go nowhere near fast. We can go a lot faster by activating those supply chains. And to me, the way to do it is to entice them with the profitability potential of these projects.
Yeah, that's interesting. Lev, you also have, a very deep oil and gas background.
Yeah.
What's it like, working with that industry, or what would you add to what Carlos shared there?
Well, I actually agree with everything that Carlos said. And the way to increase this profitability is to go to higher temperatures. Unfortunately, thermodynamics is very mean science. And if you are at 200 C or below 200 C, there is a efficiency, but driven by physics laws, and there is not much you can do. Okay, but the moment you go uh, deeper, with every degree temperature goes up, and for every degree power goes up like a cube of the temperature increase. So I don't know how many listeners know, but in Texas, we can drill 20,000 wells a year, okay, oil and gas wells. So neighbors is also our investors as well. And point being, oil and gas industry does have scale to implement terawatts, literally terawatts, okay, of geothermal power generation. Okay, they have scale, they have tool, they have equipment, they have skills. Okay, so, and as you know, oil and gas can deliver from or install from Arctic to jungles. Okay, we are as good delivering projects globally. So if we can do it profitably with a margin that Carlos was referring to, oil industry is going to support us, and we're all going to make a lot of money and build base load geothermal power generation globally.
Yeah, I think I like to add one more point. Speed matters too. I mean, you hear a lot about speed, speed to power. In my conversations with hyperscalers, data center builders, speed to power is one of the key imperatives. You know, when you increase the temperatures of this, not only are you increasing the profitability we just talked about, your ability to put capacity online shrinks dramatically. Instead of drilling 10 wells in 20 days, you can drill one well in 40 days, and you're way ahead. That's a 5x factor, right? So, you know, we've done our calculations conservatively at scale. You can put a 1 to 2 gigawatt capacity online from zero to electron dispatch at the meter in 2 years. In 2 years. And why is that? Because you can parallelize the subsurface development with the above surface development,
Mm.
and because those things exist at massive scales. 1 gigawatt in 24 months, and you can do it 10,000 times over. It's unprecedented. Nuclear cannot do that. Wind and solar cannot do that. Only geothermal can do that. The hotter, the better, and it gives you that speed in addition to the profitability.
That's really interesting, I think, because, again, that's such a conversation right now, data centers and AI and the electricity demand in the US especially, and you don't often hear geothermal, mentioned as one of these solutions that can, move fast enough. So, I mean, Carlos, you spoke to it a little bit, but what would you say to people who are, skeptical that, this technology will be able to keep pace with an industry that typically moves really fast?
I think the way to convince yourself is to understand how the world powers itself today. The status quo of the world is oil and gas. It is oil and gas. We're talking about total primary energy supply. So the world already adds 1 to 2 terawatts just to keep up with oil field declines on a global basis, not even increasing demand. So that is the first aha moment to understand that there is something already built at scale that is giving us the energy abundance that we enjoy in our modern lives, that with a small tweak, a redirection of resource that's extracted, heat versus oil and gas, will click in. Of course, you need the profit margins to do that. If the profit margins are not there, they're not going to do it. Capitalism reigns supreme in this world. So that is what I'm trying to do with what Quaise is building, is to create that redirection and make sure that the oil and gas industry sees a resource at the scale profit and the same potential, if not larger than oil and gas itself. Because only then is when everything we're talking about here happens. And what am I doing about it other than the drilling technology? I'm building the first one. I'm going to show the world, look at a geothermal version. I'm going to show the world in 2026 a flowing doublet that flows as much energy. A flowing doublet is two wells, one injector, one producer, that produces as much energy as the best of class oil and gas, oil wells or gas wells in the world. That is a massive transformational perception of what's possible. We have to show it with these companies so that people believe it and lean in. Speed is at the heart of what we do. And going deeper and harder is what's going to enable that speed and that profitability.
Yeah. Lev, I know this is top of mind for you guys too with you have a power purchase agreement with Meta and are currently also, building these projects.
Yeah.
So yeah, what would you add to that?
Yes, I just want to add a couple of points to what Carlos just said. If we would be having this discussion in mid 90s of the previous century, and I would tell you that solar is going to generate terawatts of electric power, you would think that I'm crazy. If what would tell you that we are going to produce millions of barrels of oil from shales, you would consider me crazy. Okay. And so, but all this happened. Okay. And unconventional oil from and gas was developed from idea to implementation in less than 15 years. Point being, we're here in geothermal energy, we have new ideas, and we do know how to move fast. As far as Meta and other hyperscalers, they are very interested in geothermal. They understand actually geothermal. They may not talk a lot about geothermal, but they do understand. And them signing with us and with other companies long-term power purchase agreements, that actually means that they believe, and not the same as they were the early believers in solar and wind. So it's here and it's going to happen.
This year, I mean, AI has been one of the obviously major kind of storylines. Another one has been a really big change in the US policy landscape. This new administration coming in and changing a lot about what policy looks like, what support looks like. Geothermal, I think, has been in kind of an interesting position and probably one of the more favored industries. I wonder if you could both speak to, how geothermal did or didn't fit into, former policies, what, you're looking out for in the US right now, and what it's been like working with the current administration. Lev, do you want to start us off there?
Yeah. So current administration, as you know, is very supportive of geothermal. Chris Wright, as an energy secretary, he has deep knowledge in geothermal, and he supports geothermal from a regulatory perspective. Very important is ease and time of permitting. Okay, the less time we need to wait is much better. I also want to shout out to Texas Geothermal Alliance, which helped to put together and get through our Texas legislature several critical piece of laws that now clarified who own heat, which helps a lot, especially in Texas, to quickly develop and implement geothermal energy.
Carlos?
Yeah, I think same thing. It's got support in this administration, and it also had support in the last one. I think the last administration brought it at parity with the other renewables. This administration actually brought it to the front together with nuclear and fossil. Practically speaking, I've seen it and I've lived it as we try to advance that first project in Oregon. We've seen a quick acceleration of time to permits of all kinds, building a road, building a path, doing an appraisal well, water permits. So it's nothing but positive. There's more focus right now because policy is focusing more on geothermal, nuclear, and fossil, and not so much on the other ones. So I cannot complain. I also see it internationally. There's many countries, Japan is one of them, that is engaging very closely. They see a national security and national independence, energy independence concern and opportunity, and they're already looking at putting the first one of these pilot plants over there, right? I think this one's probably 2 years behind the one we're doing in Oregon. But it goes to show that the world is starting to wake up to this opportunity to own its energy independence and abundance agenda, and nothing like geothermal to actually drive that agenda forward.
We've just got a couple minutes left here, so I want to kind of zoom out a little bit. If you look ahead into the future, think about, this tech, enhanced geothermal overall. Um, what milestone, either for your company or the industry overall, what milestone would make you stop and go, okay, I feel like we've really made it, whatever that means to you? Carlos, do you want to start us off?
To me, it's about scale. I always talk about terawatt scale geothermal. I put a North Star to my team, my commercial team, and say, how can we credibly put a 1 terawatt pipeline? It's a global pipeline, it's not just the US, a 1 terawatt, 1,000 gigawatts, 1 terawatt pipeline that is actionable by 2035, right? That means that along that pathway, we've hit that point where the capital structures of the world lean in a massive way. I think it's going to take not one project, maybe two projects of the kind that we're building for the large infra players, for the growth equity players, for the banks, the investment banks to lean in a way that will unlock trillions of dollars to build those pipelines. And the world needs this power either for substitution of existing sources or for addition. That is what I'm working towards. A 1 terawatt pipeline, not built, because building things takes long, but 1 terawatt pipeline that's actionable and well underway by 2035.
All right. Small goals. Lev, what about
Yes,
That's what the world needs.
I'll be brave. Meta Phase 1 by end of 27 at Ormat facility operational, and then super hot, super deep using our drill shallow frag deep technology, proof of concept by the end of this decade.
All right, we've got some things to look forward to from you both. Um,
Thank you very much, Casey.
Thank you so much for your time. I really always wonderful to speak with you both and really appreciate you being here.